Hello everyone, I'm Efe. I'm a senior software engineer on the Amazon Elastic Container Services team. And for the past year or so, my team and I have been working on the AWS Copilot CLI to simplify container development on AWS. So you've done already all the hard work. You containerized your application, it's working great locally, and now you want to run these containers on AWS. And today we're going to explore exactly how to do that with the AWS Copilot CLI. So in today's agenda, we're going to take a look at how to build a containerized application on AWS and all the challenges that come with it. Then we're going to see how the AWS Copilot CLI helps us solve these challenges. And then we'll see an overview of all the features that are offered by the CLI. So what is architecture as code? How do we create multiple deployment environments that are in different AWS accounts and regions? How do we create a continuous delivery pipeline? How do we monitor and operate these services in my application? Okay, let's get started. So today we're going to build for our sample application a voting app. So whether we prefer cats or dogs, and it's a simple three-tier application. So we're going to receive requests from the internet, from a load balancer. The load balancer will forward these requests into two different microservices, either the vote service to help us register our votes, or the results service to view our votes. These two microservices will communicate with a third microservice, a private API microservice that fronts an Amazon Aurora serverless database to store and retrieve these votes. From the diagram, you can see that we have a pretty simple architecture. We have only 5 different components in there. So it should be pretty easy to get started, right? Well, the reality is that we would have to create and manage 43 different AWS resources. And we'll have to do that in a secure and sensible and cost-effective way. So suddenly I would need to learn about all these networking primitives such as an Amazon Virtual Private Cloud, what are public subnets, what are private subnets, what's the difference there, what are route tables, internet gateways, internet gateway attachments. We need to ramp up on security. So security groups, IAM roles, and then we would have different primitives that are related to our load balancer and ECS services, such as task definition, Elastic Container Registry repositories, service discovery namespaces, HTTP listeners, listener rules, target groups. Whereas in reality, in our architecture diagram, we only had 5 different resources that we cared about that are highlighted in pink. But suddenly we're managing 43 different resources. With Copilot, we really think that the next phase of infrastructure as code will be architecture as code. As a developer, I only have to say, hey, I want a service that's internet facing, or I want a service that's, processing events from a queue, a worker. So, and then the infrastructure itself should be generated from my architecture type. The next challenge that we need to solve as application developers is around releasing our services, right? So, right now we talked about these 42 different resources that are in a single environment, a test environment. But if suddenly I had to create a production environment, then I would need to duplicate all these resources. So I go from managing 43 different resources to 86 different resources. Luckily, we have great infrastructure as code tools like AWS CloudFormation, Terraform, the AWS Cloud Development Kit that helps us simplify reproducing our resources into a different environment. But the process of creating an automated release process is still cumbersome. So if I had to create a pipeline, then I would need to create additional infrastructure, an AWS code pipeline, code build projects to build our containers and then push that onto an Amazon ECR repository. Or if to store my CloudFormation templates, I would need to create S3 buckets, KMS keys, IAM roles. And the final challenge that we need to solve as developers is around operating our services. So far we talked about challenges regarding infrastructure provisioning and modeling our resources. But once our service is up and running, we'll need to monitor and troubleshoot our services, right? And we don't have a single tool to do both of these. And this is exactly why we built AWS Copilot CLI. AWS Copilot is a command line interface that's open source that helps developers build, release, and operate their containerized applications on AWS. And today, I'm really excited to share that the CLI is no longer in preview, and it is now generally available so that you can build your containerized applications, production-ready containerized applications using the CLI. Here's a code from one of our customers at class method that used the tool while it was in preview, and it really captures the essence of Copilot on how it solves the build and release challenges. The amazing thing about Copilot is that it allows us to create a production-ready ECS environment that comes pre-integrated with other components necessary for production workloads, like a CI/CD pipelines, all with the ease and barest minimum resources to prepare beforehand. So how do we solve the first challenge? How do we build a containerized application with Copilot? I only need to run Copilot init. Then the CLI is going to prompt me for which workload type best represents my service, right? So for example, the vote service as well as the result service were both behind a load balancer that were receiving requests from the internet. So I want to choose in that situation a load balanced web service. That describes my architecture of my service. The API service, on the other hand, was a private service that was only receiving requests within my VPC through service discovery. It wasn't accessible from the internet. In that situation, I would choose a backend service type. Or if I have a task that's scheduled periodically on a particular schedule, then I would choose a scheduled job. From there, the CLI is going to generate all these 43 resources for you. So we generate the infrastructure from the architecture type that best represents your service. We'll do that in a secure and sensible way. The next input that the CLI is going to request from you will be the Docker file that's in your repository. So the CLI is going to scan the repository, it will find all the Docker files that's in it, and then it's going to ask you which one you want to use. Then it's going to build your container image and then push it to Amazon ECR. So you don't have to use a separate tool to build your containers and then push them. It's all baked into a single tool, into Copilot. Now we understand that you will have particular requirements and then Copilot might not provide all the integrations that's needed for you by default. So you can grow your applications using the add-ons feature. I can take any CloudFormation template that I want, again, drag and drop it to a Copilot directory, and that will be integrated with my service. So we'll see exactly how we'll do that in a demo pretty soon. If you remember, our API service was connected to an Amazon Aurora serverless database, and that's done through the add-ons feature. Or Copilot provides native integrations by default for you as well through the Copilot storage init command. So if I type storage init, then it's going to ask me if I want to create an Amazon S3 bucket or an Amazon DynamoDB table, and then we'll generate the CloudFormation template for you. Okay, so let's take a look at a demo of how to get started with Copilot. Just to recap, in our vote application, in our voting app, we had 3 different microservices: a vote service, an API service, and then a results service. For each one of those, I created a separate Git repository. And right now, I'm at the root of my vote repository, and I'm going to type Copilot to get the help menu of the CLI. So over here, I type Copilot, and then I get the help menu of the CLI. You can see that from the CLI, it says that it helps me launch and manage applications on Amazon ECS and AWS Fargate. Under the commands, we have different categories for the CLI. So we have a getting started section with the commands like init and docs to view the docs of Copilot. Then we have more advanced categories under develop, release, and if I want AWS integrations with my services, I would look under the add-ons category. But since I want to just get started, I'm mostly interested in the getting started section and the init command. So I'm going to type Copilot init into the terminal, and then I'm going to create my first service. So the CLI immediately says, welcome to the Copilot CLI. We're going to walk you through some questions to help you get set up with an application on Amazon ECS. An application is a collection of containerized services that operate together. The first question is, which workload type best represents our architecture? So if you remember from our architecture diagram, our load balanced web service, our vote service was a load balanced web service. It was behind the load balancer accepting requests from the internet. So I choose the load balanced web service type, and then I name my service to be just vote. So I type vote for this question, and then next the CLI scans my repository, finds the Docker files that's in the repo. I have a single Docker file in this situation, so I'm going to choose my Docker file, and then it's going to start generating all the infrastructure needed to schedule to create my vote service. So I've already done this deployment because it takes roughly 10 minutes to deploy the service. Instead, I'm going to switch over to the next tab so we can see the user experience that Copilot provides during deployments. right? So you can see that we build our container over here, and then we start pushing it to Amazon ECR. And then at the end, once the deployment is done, Copilot tells me that we deployed the vote service and you can access it at this particular URL. So I can take this URL, and now if I copy and paste this into the browser, we should be able to see the UI for our vote service. Perfect. So I can see that I can vote between cats and dogs. In this situation, I prefer dogs, so I'm going to choose dogs over here. And I ran Copilot in it for all three of my services. So as well as, so I deployed already my vote service as well as my API service. So if I take the same URL, go to a new tab and type /results, I should be able to see the results of all the votes. And my team prefers dogs, so dogs win. Okay, so far we have learned how to get started with Copilot. I only have to type a single command, Copilot init, and that creates my application and my service for me. Now let's take a look at how we would grow our application and tailor to our requirements. So I switch over to my IDE, and you can see that I have a separate repository for each one of my services, like mentioned earlier. So I have a separate directory for API, results, and vote. I'm going to go under the vote repository. And if I click on it, you can see that after I ran Copilot init, we created a Copilot directory for you in the repo. Under Copilot, we have a separate directory for the service that I just initialized. So if you had a mono repo, if you had, for example, your API service, your results service, as well as the vote service under a same Git repository, then you would find a separate directory for each one of your services under Copilot. So vote would be there, API would be there, results would be there. But since I have a single repository for only vote, I have only the vote directory in there. So I open up vote, and then I open up my manifest file. And the manifest file is just infrastructure as code for a particular architecture. In this situation, it's the best way to represent a load balanced web service. So what are some common configurations that we might have for a load balanced web service? We'll have the port that's exposed. Then we'll have, under the HTTP section, the path that we're listening on from the load balancer, as well as the health check path. Then we'll have configurations for our container, so the CPU, memory, how many tasks we want to run, part of the service. And then we have some other configurations, such as being able to set up environment variables, secrets, or environment level overrides. So I should be able to say, for example, hey, for test, I want to keep things cheap with a single service, a single task that's running part of my service. But for in production, I want to be more resilient, and I would set my count to be 10, for example. Okay, so let's take a look at what this manifest file will look like for a different service type. So I'm going to open up the same manifest file for the API service. So I navigate under API to Copilot, then the API directory, and underneath it I should find my manifest file. And you can see that the manifest for a backend service does not have the HTTP section. It's not a public load balanced web service, so there is no HTTP field, but it's pretty similar otherwise to a load balanced web service. Under the health check, I set up my container health check for the backend service. My CPU and memory settings are much higher for my API service. I need more resources for it. And under count, instead of specifying a single number, I specified a range. So I can set up auto-scaling, right? So I can say, hey, my service should always have between 1 or 10 tasks that's running, and I want to maintain 70% CPU for auto-scaling. Okay, and from the architecture diagram, let's remember that our API service was connected to a Amazon Aurora serverless database. And the way that we grow our application is under the add-ons directory, I can drag and drop any CloudFormation template that I want, and Copilot will figure out how to connect that CloudFormation template with your service. So I took a CloudFormation template for an Aurora serverless database. You can see all the resources that are defined in there. We should be able to see the RDS DB cluster that's as well defined over here. And Copilot will create this CloudFormation stack for me and then deploy it. So if I switch over to the CloudFormation console, you can see all the CloudFormation stacks that are created by Copilot for me. So you own the resources, you get visibility in all these resources. We tags these resources for you so you can associate costs with your services. And if I switch over to the RDS tab, we should be able to see that indeed the RDS cluster, DB cluster that was defined in my CloudFormation template is indeed created. Okay, so we learned how to build, how to get started with Copilot, as well as growing our application, our services to the requirements that we needed. Now let's take a look at how we would tackle the second challenge around releasing our application. So we will need to figure out a way of creating multiple deployment environments that are ideally in different AWS accounts and regions. Right? Let's say that my test environment I live in Seattle, so I would choose my test environment to be in US West 2, for example, but maybe my production environment needs to be closer to my customers and I want it to be in US East 1. So the way I would do that with Copilot, I would type Copilot env-init, and then the CLI is going to ask me which credentials I want to use to create my new environment. So I would choose the profile that would point to a different AWS account and a different AWS region. In this situation, I would pick profile prod IAD, and that will create a brand new deployment environment for me. Afterwards, I have two different options to release my service, to deploy my services. Right? I can do that manually. So I'll show that in the demo in just a second. I could type Copilot deploy and then choose to deploy to a production environment, or I can set up an automated release process. So I would run Copilot pipeline init, and that will generate for me a Copilot pipeline manifest, and then I can deploy the pipeline through the manifest and just get a continuous delivery pipeline for me. So let's quickly take a look at a demo of how the release process works with Copilot. So just like before, I'm going to switch over to the terminal and I'm going to type Copilot from the root of the repository. And you see that I get back my help menu. In this situation, I'm interested in the environments section. Environments are deployment stages that are shared between services. So I type Copilot env and I get the help menu for the env family, env command family. So under environments, we have env-init, env-ls, env-delete, env-show. But since I want to create a brand new environment, I'm going to type Copilot env-init to the terminal, and that should help me set up a brand new environment. Okay, so the first question is the name of my environment. I'm going to name it prod IAD. Then the CLI is going to ask me which credentials I'd like to use to create my production environment. I'm going to choose my prod IAD profile so that it creates it in a different region than US West 2. It should create it in US East 1 for me. So I choose prod IAD. And then the CLI is going to ask me if I want to create my environment with the default configuration, right? So in this situation, I'm going to say, yes, I want to create with the default configuration. But if I have an existing VPC and an existing subnet, then I can always import an existing resource. I could import an existing VPC. I said, yes, use default. And then you can see that the CLI starts linking my account and then creating a new environment in the region that I specified in my profile, US East 1. So I've already done this deployment, and I switch over to the next step to be able to view the UX that Copilot provides. So while the deployment is happening, Copilot will tell you that it's creating a virtual private cloud with 2 availability zones. It has an internet gateway, public subnets, private subnets, your ECS cluster, as well as the application load balancer to distribute traffic. And then at the end, it tells you that it has indeed created your environment and it's in US East 1. So now if I switch over to the CloudFormation console, you can see that I'm in US East 1, and there is a CloudFormation stack that was created for me under voting app-prod IAD. So my new environment is created. Now, if I want to deploy to this environment, I have two options. I can do a manual deployment by typing Copilot deploy, and then the CLI is going to ask me which environment I want to deploy to. Since I have two environments, I can choose between test and prod IAD. But I'm not going to do that. Instead, I'd like to show how we can set up a continuous delivery pipeline. So I'll switch over to the next terminal, and I type Copilot to get the help menu, or Copilot pipeline, so we get the help menu for the pipeline command. So you can see that the Copilot pipeline menu tells me that this is to manage continuous delivery pipelines, to release your services. Just like before, I'm interested in the init command, so I type Copilot pipeline init. And then the CLI is asking me for which order I want to do my deployments. So I would like to first deploy to a test environment and then to my production environment. So I choose test and prod, and then I give my access key, my GitHub access token, and then Copilot generates for me two files, a pipeline file as well as a build spec. And we're going to take a look at exactly what that pipeline manifest file contains in just a second. At the end, you can see that Copilot is telling me to run Copilot pipeline update to deploy my pipeline for the repository. So that's exactly what I'm going to type over here to create the CloudFormation stack to create my pipeline. But since I've already done this, I say no over here, and instead we'll go switch over to the console and we'll take a look at how our pipeline looks like. So the first stage that's in our pipeline is our source stage. This will pull the source code from your Git repository, and then the next stage that's going to be triggered afterwards will be our build stage. So in the build stage, we know the location of your Docker file that you specified in the manifest. We'll build the container image and then push it to an Amazon ECR repository for you. And then afterwards, we're going to trigger the deploy to test stage. So a CloudFormation deployment is going to happen, and our service will be deployed to a brand new environment. Finally, the last stage that we had specified was to deploy to production. And you can see that in deploy to prod, I have a manual approval button before actually triggering my CloudFormation deployment. So I can press on review and then approve my deployment, and then you should trigger my CloudFormation deployment. So you can see that it starts deploying to CloudFormation, to my production environment. Okay, so let's take a look at what the pipeline manifest file looks like. And the manifest file for a pipeline just describes the shape of your pipeline. So if you remember in the console, we saw that the pipeline contained two different stages. It had a test stage as well as a production stage. So the first stage that I defined is named test, and then afterwards I defined my production stage. And in my production stage, I had a button in there, a manual approval button, and I can specify that in the manifest with the requires approval field and set that to true. If I want to set up integration test or end-to-end test, I would do that with the test commands field. So I could uncomment this line and add my own test to run after the deployment happens. Okay, so we learned how to release our service. The next challenge that we need to discuss is around operating our services, right? So for example, if I wanted to change a single field in my database or do some sort of schema migration, I can always run the Copilot test run command to create one-off ephemeral tasks that run in my VPC. If I want to view the logs of my service, then I can stay in my terminal and I can just type Copilot service logs -- follow, and that will tail the logs for my service. Or I can type Copilot service status to view the health of my service. So let's do a demo and let's take a look at some of those operational commands that's available to me. So just like before, I go to the root of my repository, and I type Copilot, and I should be able to get the help menu. In this situation, I'm interested in the service command family. So I type Copilot service, and at the bottom, we can see that we have two different commands that's available, status and logs. In this situation, I'm first interested in viewing the logs of my service. So I'm gonna type Copilot service logs -- follow to tail the logs. And the CLI is going to pick up all the different services that's available for me. The API service, the voice service, as well as the results service. I want to view the logs of the results service, so I choose that, and then you can see the logs are outputted into the terminal. Now if I go back to the browser and I refresh the page, I should see a brand new entry in the terminal. And you can see that a new line was emitted, and indeed the logs appear in the terminal. Okay, so now let's take a look at the health of one of our services. So I type Copilot service status, and then the CLI is going to ask me again which service's health I want to view. So instead of results, let's take a look at the health of the API service. I choose API, and then the CLI is displaying to me the health of my service. So we have one task that's running, so no auto-scaling happened. The last update was 16 minutes ago. My service is healthy, and then you can see the alarms that are managed through Copilot under the alarms section of my table. So these are the two different alarms that are needed for auto-scaling. Okay, so to recap, we really built the AWS Copilot CLI so that developers focus on delivering business value and not worry about the underlying infrastructure. We do that by providing a really easy way to get started with running your containerized application on AWS with the Copilot init command. We take a single input, your Docker file, and then you tell us, which service type best represents your architecture, and we generate all these underlying infrastructure resources for you. We wire them securely and sensibly. When time comes for you to modify the requirements and go beyond the defaults that Copilot provides, you can modify the manifest file, to change your container sizes, to change the count of your service, to add auto-scaling, to add environment variables, secrets. And if you need more AWS integrations with different AWS services, then you can grow with the add-ons feature. If you need to operate your services and debug and troubleshoot, you don't need to leave the comfort of your terminal. You can just stay in your terminal, type Copilot service status or Copilot service logs to view the logs of your service. And then finally, so that you can release frequently, add as many features as you can, as well as rapidly respond to failure events, we provide an easy way for you to set up a continuous delivery pipeline. This CLI is open source and it's available on GitHub. You can find the repository at github.com/aws/copilot-cli. The documentation is also hosted on GitHub, and it's available at aws.github.io/copilot-cli. And if you want to learn about all the features that Copilot provides, check out Adam and Brandt's videos on Containers from the Couch. Thank you so much, and please complete the session survey.